Welcome to Spring LIB.
Okay, so we're doing chapter 29, problem 21. And this has a figure here. We have a circular loop that's surrounded by another bigger circular loop that is connected to a battery. And this battery is connected to a switch. We'll call that switch S. Okay, so we want to use Lenz's law to figure out the direction of the current that is induced in this small ring in the middle here. Okay, so let's first imagine when the switch is closed, we have a current around that's flowing around counterclockwise. So with S closed, I is counterclockwise. So B is, using the right hand rule, out of the page. Okay, so part A asks us to figure out the direction of the induced current just after the switch is closed. Since we start with an initial current of 0 with the switch open, the change in current is greater than 0. So dB dt is greater than 0, which means the change in flux greater than 0, and that means it is out of the page and increasing. So to oppose that, Lenz's law says the current induced must induce a B field or make a B field out of the, or into the page. Sorry, this dot is out of the page, so the changing is out of the page and increasing, so the induced current must oppose that by making a B field into the page. So B induced is into the page. Using the right hand rule, we see that it must be a clockwise current. Okay, so now go to case B. So B says after S has been closed a long time. So when S is closed a long time, the circuit is steady. We just have our current going and going and going. We have nothing changing it at a time, so di dt equals 0. And if there's no change in flux, that means there can be no induced current. So no change in flux leads to no induced current. Awesome. So part C. C says just after S has been reopened after it was closed for a long time. So if it was closed for a long time, that means we have a large or have a steady positive current. We open it, that means this current's going to drop. So we have the exact opposite case of here. So that means we have a flux that is out of the page, but now decreasing. Lenz's law then says that the B induced must be out of the page to oppose the out of the page decreasing. And using the right hand rule again on our little loop, that means this must be a counterclockwise current now, which is just the opposite case of part A, which is exactly what we would expect.